All right, today we are going to go over stoichiometry. Stoichiometry is just a fancy word for calculating the amounts in a chemical reaction. So this is where we're going to put the math or the numbers into the reactions that we've been predicting and balancing. All right, before we start with chemical equations, let's start with something that we're all familiar with, a recipe. So today, instead of focusing on reactions, we're going to start by focusing on ham sandwiches. So let's say that we are making a ham sandwich and the recipe calls for 2 pieces of bread, 3 pieces of ham, 1 piece of cheese, and together all of those make one sandwich. So what we are going to do is we're going to calculate the amount of ingredients that we need based on the recipe that we have. All right, so I'm going to use the recipe for my ham sandwich to figure out how many sandwiches I can make if I have 35,204 pieces of bread. Now, I know that you can pick up your calculator, or a lot of you can just do this in your head, but the setup here is going to be really key because this is the same setup that we are going to use when we start applying it to chemical reactions. All right, the very first thing you want to do is identify the 2 ingredients that you care about the amount of. So if I read through this problem, it's asking me how many sandwiches. I'm going to find sandwiches in the recipe and identify it. And I want to know how many sandwiches I can make if I have 35,204 pieces of bread. So even though all of the ingredients are there, the 2 that I care about in this problem are the bread and the sandwiches. And notice that the coefficients in front of these are going to tell me the ratio of bread to sandwiches. For every 2 pieces of bread, that is going to produce 1 sandwich according to the recipe. Those are equal values for this recipe. Now, when we start a stoichiometry problem, you always want to use dimensional analysis, and you're always going to start with the number that is given in the problem. I'm going to start with my 35,204 pieces of bread, and I'm going to multiply. And I'm going to multiply by a fraction. Remember that when I'm using dimensional analysis, the top and the bottom of the fraction have to be equal values, just different units. And that's exactly what these are. In this recipe, 2 pieces of bread will equate to 1 sandwich. So I'm going to put the 2 pieces of bread on the bottom, the 1 sandwich on the top. That will allow my unit of bread to cancel out, and all I'm left with is sandwiches, which is what the problem asked for. So I know I'm done. In order to solve this, I'm going to multiply across the top of the fraction, multiply across the bottom of the fraction, and divide the top by the bottom. That is going to give me 17,602 sandwiches. So if I start with this amount of bread, I know exactly how many sandwiches I'll be able to make. We are going to take this exact same theory and apply it to a chemical reaction. All right, instead of a recipe, notice that I now have a chemical equation. I know that N2 reacts with 3 H2s to produce 2 NH3. The question is asking me how many moles of NH3 are produced when 1.25 moles of H2 react with N2. So again, I'm going to approach this the same way I did the sandwich problem. I'm going to identify the 2 substances that I care about the amount of. It's asking me how many moles of NH3. So I'm going to find NH3 in the balanced equation. Then it's telling me 1.25 moles of H2. I'm going to identify the H2 in the reaction. Now I want to compare those 2 substances only. And those 2 substances will always react in a 3:2 ratio based on the coefficients that are out front. Now, the key to a balanced equation is that my ratio only works when I'm in the unit of moles. So I know that 3 moles of H2 is exactly equal to 2 moles of NH3 in this equation. I suggest when you're first getting started with this that you always write that ratio down before you begin, because I think that's going to help you as soon as you start to set up the dimensional analysis problem. When you're ready to begin the problem, you are going to start with the number in the prompt every single time. I know that I have 1.25 moles of H2. Notice that I'm making sure that I put the unit as well as the substance as a label on my number. Then I'm going to multiply that by a fraction. Remember, the top and the bottom of the fraction have to be equivalent to each other, just different units. And in this particular reaction, I know that 3 moles of H2 will produce exactly 2 moles of NH3. So now one of those needs to go on the top and one on the bottom. In order to decide what goes where, I'm simply going to match my unit. Since I have moles of H2 on the top, I need moles of H2 on the bottom, and the number that goes with that is 3. For every 3 moles of H2, I am going to produce 2 moles of NH3. My moles of H2 cancel out with my moles of H2. All I'm left with now is the unit of moles of NH3, and that's exactly what the problem asked me for, so I'm done. When I'm done, I'm going to solve this by multiplying across the top, 2.5, multiply across the bottom, 3, divide my top by my bottom, and when I do that, I get 0.833. Now, it's important that you always put a unit on your number. The only unit that didn't cancel out in this problem was moles of NH3, so that is the unit that belongs on my final answer. Now, it's important to remember that these numbers have meaning. What this is telling me is that if I were to run a reaction, the reaction right up here, and I started with 1.25 moles of H2, I can predict that I would make exactly 0.833 moles of NH3. All right, let's look at a second problem. I'm going to use that same balanced equation, but this time I want to know how many grams of NH3 will be produced when 2.8 moles of N2 reacts with an excess of H2. All right, again, I'm going to start all of these problems the same way. I'm going to read through and determine what 2 substances I care about the amount of. It's asking me how many grams of NH3. So I'm going to find the NH3 in the equation and identify it. I want to know how much will be produced when 2.8 moles of N2. So 2.8 moles is my other substance that I care about, and that pertains to the N2. I'm going to find that in the equation. It's telling me that I have an excess of H2, but notice it's not asking me how much H2. So I don't need to worry about the H2 in this particular problem. Once I identify the 2 substances I care about, I'm going to find the ratio between them. Remember that 1:2 ratio only works when we are in the unit of moles. So if there's no coefficient written in front of a number, that implies that there's one of them. So I know that for every 1 mole of N2, that is going to produce 2 moles of NH3. All right, I would suggest again always writing that ratio down until you are really confident with these problems. Next, we're ready to begin the setup. Your setup should always start with the number in the prompt as your starting point. So I'm starting with 2.8 moles, and specifically moles of N2. Make sure that you're labeling not just the unit, but also the substance. You are always going to multiply, and you want to make sure that the top and the bottom of the fraction are equal. So I have moles of N2. Since I'm in moles, I'm ready to use that mole ratio from the balanced equation right away. For every 1 mole of N2, I get 2 moles of NH3. I chose to put the moles of N2 on the bottom so that my units would cancel out. Now, if I stop the problem here, the only unit that hasn't canceled is moles of NH3. But notice that the problem asks me not for moles, but for grams of NH3. That means that I'm going to have to do a second conversion and continue the problem on. So rather than stopping here, I'm going to do one more step, and in that step, I'm going to convert my moles into grams. In order to get from moles to grams, I'm going to have to go to the periodic table. I'm going to add up 1 nitrogen, which has a mass of 14.01, 3 hydrogens, which have a mass of 1.01. When I add this up, I end up with 17.04. Whatever number I get off the table tells me how many grams are in 1 mole. And remember that this is true for NH3. There's 17.04 grams in 1 mole of NH3. Now when I do the next step, I'm just trying to get from moles to grams. And again, the top and the bottom have to be equal values. So since these are equal, one can go on the top and one can go on the bottom. I'm going to choose to put 1 mole of NH3 on the bottom so that my units of moles of NH3 cancel out. 1 mole of NH3 is exactly equivalent to 17.04 grams of NH3. Now the only unit that has not canceled out is grams of NH3. And that is exactly what the problem asked me for, so I know I'm done. When I multiply across the top, I get 95.4. When I multiply across the bottom, I get 1. I divide my top by my bottom, and I end up with 95.4. Now, it's important that we put a unit on that final answer The only unit that didn't cancel out was grams, and specifically grams of NH3. It's important to remember what this number means. If I were to run the reaction here, starting with 2.8 moles of N2, I can predict that in the lab, I would produce exactly 95.4 grams of NH3. All right, I'm a visual person, and I think sometimes it's easier to see what you're doing rather than trying to just keep it all in your head. So I have made a visual here. And I think that sometimes people get lost because they're not sure really how far do I go or how many steps do I do. Well, this graphic can be a good way to help you if you're having that problem. The central point of every single one of these problems is to compare moles of one substance to moles of another. This is the part of the problem that you are going to do every single time. In order to do that, you are going to need to use the mole ratio from the balanced equation. So these are the coefficients from the balanced equation. That is going to be the core or central part of every single problem. Now, some problems will have you start in grams, and if you start in grams, we still want to use the mole ratio, but we can't use the mole ratio until we're in the unit of moles. So sometimes you will have to do a first step in which you add up the molar mass on the periodic table to figure out how many grams are equal to 1 mole. Again, this is coming from the periodic table. Likewise, after you use your mole ratio and you convert from moles of A to moles of some new substance B, sometimes it'll ask you for a final answer that's in grams, not in moles. And if that's the case, you would need to go one step further. Again, to go from moles to grams, we simply look at the periodic table and add up the masses of all of the individual elements. When we add them up on the table, whatever we get as our answer is the number of grams equivalent to 1 mole. And again, that number comes from the periodic table. All right, so let's try one more problem and see if we can use this chart to help us out. I have a balanced equation up here. CH4 plus 2O2 produces CO2 plus 2H2O. I put my little graphic here so we can use that as a helpful hint to figure out where we're starting and where we're going. All right, I want to know how many grams of H2O will form from 18.8 grams of CH4. I'm going to start this problem just like I did the previous two. I'm going to start by identifying what two substances I care about the amount of. It asks me how many grams of H2O. So I'm going to find H2O in the balanced equation. Will form from 18.8 grams of CH4. So I care about the amount of CH4 and the amount of H2O. I want to use the ratio from the balanced equation. So in order to use the ratio, I need to compare the coefficients of the two substances that I care about the amount of. Again, if there's no coefficient written, that means that there is only 1 mole of CH4 for every 2 moles of H2O. My job is to use this mole ratio, but I can only use the ratio when I'm in the unit of moles. So let's start the problem with the number that's given. I'm starting with 18.8 grams of CH4. Notice that I am starting with grams of some substance, the substance being CH4 here. So I know I'm starting right here with grams of some substance. Then it's asking me to find grams of an entirely new substance. So instead of substance A, I'm now looking for some new substance B. That means that I'm going to have to go all the way from grams of A to moles of A to moles of B to grams of B. All right, so if I am wanting to use the mole ratio that I've identified, I need to first change this into moles. I can do so by going to the periodic table and figuring out how many grams are equal to a mole. I'm going to add up 1 carbon, which is 12.00, and 4 hydrogens, which are 1.01. When I add those up, I get 16.04 grams are equivalent to 1 mole of CH4. Top and bottom of my fraction need to be equal, and I'm going to put the 16.04 grams of CH4 on the bottom and the 1 mole of CH4 on the top. This will allow my grams of CH4 to cancel out. Now, if I stop the problem here, I'm in the unit of moles. So I have moles of my new substance. Now I'm going to take those moles and change them over using the mole ratio that I identified above. I'm going to multiply again, and I know that these are equal amounts, so one can go on the top and one on the bottom. I'm going to choose to put 1 mole of CH4 on the bottom and 2 moles of H2O on the top, because that allows my units to cancel out. If I stop the problem now, I have moles of water. But the problem's not asking me for moles of water, it's asking me to find grams of water. In order to find out how many grams are in a mole, I'm now going to have to do this last step and go to the periodic table in order to convert my grams into moles. When I go to the periodic table, I'm going to add up 2 H's, each of which have a mass of 1.01, and I'm going to add up 1 oxygen, which has a mass of 16.00. When I do that, I get 18.02 grams equals 1 mole of water. Since these are equal amounts, one goes on the top, one goes on the bottom of my fraction, and 1 mole of water is going to produce 18.02 grams of water. The units of moles of H2O cancel out. And notice that in the problem, the only unit that hasn't canceled out is grams of water, and that's exactly what the problem asked me for. So I know I'm done, and I'm ready to pick up my calculator at this point. When I multiply all the way across the top, 18.8 times 1 times 2 times 18.02, I get 677.55. Then I'm going to multiply across the bottom, 16.04 times 1 gives me 16.04. Now I'm going to divide the top by the bottom. When I divide, I end up with 42.2. Don't forget that you need to put a unit and a substance on this. I know that the unit is grams of water because that is the only unit and substance that did not cancel out in my entire problem. So what does this number mean? This means that if I ran this reaction starting with 18.8 grams of CH4, I can predict that I would make exactly 42.2 grams of water when I ran the experiment. All right, I hope that helped clear up your questions on stoichiometry. Thank you for watching. Don't forget to check out my other videos.